Good morning. How are you guys doing? It's so exciting to be here in San Francisco with so many press, analysts, and friends and partners in the audience. And welcome to everyone who's joining us online around the world. Today is an exciting day. We have a whole bunch of news to share with you today, so let's go ahead and get started. Now, you guys know us well. At AMD, we're all about pushing the envelope in high performance and adaptive computing to create solutions to the world's most important challenges. Whether you're talking about the cloud or enterprise or 5G or networking, AI, automotive, PCs, and much, much more, AMD technology is truly everywhere, touching the lives of billions of people every day. Now, this is an incredible time for AMD. We have so much innovation going on. We're actually in the middle of introducing 4 new architectures and dozens of new products as we deliver an incredible pace of products and innovation. We started in September with our Ryzen 7000 desktop processors, which were our first CPUs powered by the Zen 4 core. And then just last week, some of you were actually in the audience, we launched the new RDNA 3 gaming GPU architecture with our Radeon RX 7900 series. And we also have our Zen 4C core, which is optimized for cloud-native computing, and our next-gen AMD XDNA architecture that Victor and his team are developing. And they're both looking great and on track to launch in 2023. But today, we're here to talk about our 5-nanometer Genoa server processors. And I've got to tell you, I'm incredibly excited with what we're going to show you. Now, you know, we've said the data center represents our largest growth opportunity and the #1 strategic priority for our company. And when you think about the modern data center, you know, customers need the highest performance compute engines actually across the board. So in addition to our leadership EPYC processors, we also offer a very full portfolio, including our Instinct GPU accelerators built for our HPC and AI, our leadership FPGAs and adaptive SoCs through our acquisition of Xilinx, and our leadership DPUs from our acquisition of Pensando. So if you look at all of this, this is really the broadest data center portfolio in the industry. But as I said earlier, today is all about EPYC. So we're laser focused on building the world's best data center CPUs. We launched our first generation EPYC in 2017, featuring our original Zen core. And over the last 5 years, we've consistently delivered 3 generations of EPYC. Today, 3rd gen EPYC is the highest performance and most efficient server CPU in the world. We're extremely proud of that. And when you look, you know, in the cloud, EPYC has actually become the industry standard based on our performance, our compute density, and our total cost of ownership. Every major cloud provider has deployed EPYC in their internal workloads and in their external customer-facing workloads. And if you look today, there are nearly 600 public EPYC instances available across everywhere. Now, if you look at high-performance computing, we're also incredibly proud of the important scientific research that's conducted every day with EPYC. Today, 5 of the top 10 most powerful supercomputers and 8 of the top 10 most efficient supercomputers are using EPYC, including Frontier, which is the world's first exascale supercomputer, and it's both the fastest and the most efficient in the world. Now, in the enterprise, we also see very strong adoption of EPYC. This year, we increased our on-prem enterprise deployments by more than 50%, and we're significantly growing the number of EPYC-based solutions available across the ecosystem, and we're on track to double the number of solutions in 2023. Now, when CIOs are looking to modernize their data center, they are actually considering a number of different factors. First and foremost, compute is actually used to transform and drive the core business of the organization. All of us are doing the same. But when you're selecting compute, you actually want to make the right selection, and it makes a big, big difference in terms of the OpEx and the CapEx budgets and what you can accomplish within a certain envelope. And of course, we're also thinking about sustainability and security as key things to consider. This is why choosing the right data center CPU is more important than ever. And we thought about all of these factors when we developed 4th gen EPYC. And the key areas that we were focused on were to make the world's best server CPU roadmap even better. So I'm very proud to say that 4th gen EPYC delivers leadership on every single dimension. It's the highest performance. It's the most efficient. and we're delivering significantly better performance per watt than our competition. And what that means for enterprises and for cloud data centers, it translates into lower CapEx, lower OpEx, and lower total cost of ownership, including all of the performance that we talked about. Now let me tell you just a little bit more about 4th Gen EPYC. So we're using our leadership 5 nanometer technology, and we have up to 96 5 nanometer Zen 4 cores. And we're also using our next generation chiplet technology. So we're using a combination of 5 nanometer and 6 nanometer technology. We've also added the latest I/O, so that includes PCI Gen 5, 12 channels of DDR5 memory. We support CXL memory expansion, and we've also doubled the number of confidential VMs. So, Drew, please. I am extremely excited to show you today for the first time 4th Gen EPYC. I love it too. I love it too. There's incredible technology here, and what you can see is 12 compute die. So these are the small dies in 5 nanometer technology. That's where we put all of the computing, all of the CPUs and all of the cores. And then you see the I/O die in the center, which is built in 6 nanometer technology. And what you have on this package is a total of 90 billion transistors. So that's a lot of transistors. Now let's look at what we can do with all of that performance. Starting first with the cloud. So when you think about cloud applications, integer performance is key. And so looking at second rate, which is a benchmark, looking at it, we would say today, dual socket 3rd Gen EPYC is 40% faster than the top of the stack of the competition. But with 4th Gen EPYC, we actually extend that lead, and we now deliver nearly 3 times better performance than the competition. What that means is the core density advantage of 4th Gen EPYC allow our cloud service providers to support more than double the number of instances per server. And what that means for our customers, end customers, is that each of them get to experience these instances with much higher performance. So we're very proud of the deep partnerships across all of the cloud service providers. Now let me talk a little bit about high-performance computing. High-performance computing is very, very important for complex modeling and scientific research. And here, floating point performance is really critical. So when you look at 3rd Gen EPYC, we're already the world's fastest CPU in supercomputing. And when you go to 4th Gen EPYC, that extends our leadership to deliver 2.5 times more performance than the competition. And what this means is that scientists can build more accurate models that can help solve the world's biggest scientific challenges, whether you're talking about climate change or renewable energy development or any type of medical research. All of that is helped by more computing capability. And if you look at the enterprise, there are also a diverse set of workloads there, whether you're talking about databases or big data analytics or virtualization or hyperconverged infrastructure. And Java is one of the most prevalent environments in the enterprise. So if you take a look at Java performance running in a typical e-commerce environment, again, 3rd Gen EPYC already delivers 50% more performance than the competition. And we see an even larger performance lead with 4th Gen EPYC, going to 2.9x more performance than the competition. And what this allows is enterprises to process data faster, to speed up analytics, to speed up decision-making, as well as transaction processing. And so when you see all of that, there's so much advantage on the performance side. But as I said, just like our cloud partners, our enterprise partners are also looking for energy efficiency. And that's become much, much more important. So let me take you through an example of the energy efficiency discussion. A typical enterprise may have 15 Xeon servers in a rack. And last year, the average energy cost was 8 cents per kilowatt hour. So to power that rack, it might have cost $8,400. Now, if you use 3rd Gen EPYC, you could do that same work in 10 servers. So that's less CapEx, but dramatically less power consumption as well. And so the energy cost in that case would have been 32% lower than our competition. But we all know that energy prices around the world have gone up. And in certain parts of the world, energy costs have increased more than 5 times in the last year. And so those same 15 servers now cost maybe $50,000 a year to power. But with 4th Gen Teckykk, an enterprise can achieve that same performance in only 5 servers. That's dramatically less CapEx, but that's dramatically less OpEx as well. And that leads to a 54% savings in energy costs. And if you scale this example to an enterprise running thousands of servers, you're now seeing that you can save millions of dollars by upgrading to 4th Gen Teckykk. We're incredibly excited about Teckykk and all of the work that we've been doing together with our partners. Now let me turn it over to Mark Papermaster to tell you a little bit more about the technology and the architecture. Mark?
Such a proud day for us at AMD to share with you the technology that the team has come together to deliver for our customers. When we launched the design of our Zen CPU processor, we set a goal to return AMD to high performance and sustained high performance CPU delivery. And today, I'm really excited to share with you how the Zen 4 CPU architecture is delivering for 4th Gen Teckykk servers. There's several architectural and technology improvements compared to Zen 3. We added a new front-end design to better feed our execution pipeline. We also improved our branch prediction to further streamline the instruction pipeline flow. We improved our cache hierarchy with a fast private 1 megabyte L2, doubling its size from previous generation, and a large shared L3 cache for overall higher performance. And also, you know, AMD has long supported the advanced vector extensions in x86 for machine learning and high computation workloads. With Zen 4, we expanded our instruction support to include AVX 512. Our implementation uses a double pumped approach on a 256-bit data path. And what this is designed to do is prevent any frequency fluctuations while you're running AVX 512 workloads. And it's really delivering all of that benefit of AVX 512. This capability is targeted to heavy lifting HPC applications like molecular simulation, ray tracing, physics simulations, and more. Zen 4 is simply the latest testament of AMD execution excellence. Thank you. I'm very happy to bring up Dan McNamara to stage. Dan?
So with Teckykk, it all starts with core counts. And you already heard today, our top of stack is 96 cores. It's a full 32 cores more than our market-leading Milan processor, and more than 2x our competitor's current top of stack processor. But it's not just about core counts. Most of the enterprise workloads desire a much stronger core. So we did a little bit of an analysis here. And we took our 4th Gen Teckykk 32 core and compared it against our competitor's 32 core Ice Lake. As you can see, we're delivering up to 55% higher per core performance. This density and performance is what has our customers and partners, some of who you've already heard from today, so excited to launch new platforms and services based on 4th Gen Teckykk. Enterprises rely on relational database management systems to help with decision-making and analytics. In the enterprise, today, your analytical capability is one of your key differentiators. So, as you look at the picture on the left, we did a test with our top of stack 4th Gen Teckykk versus Intel's 8380. And as you can see, we're delivering more than 2.5x the performance for business critical queries. And transaction processing is critically important for the enterprise as well. Whether you're in e-commerce, financial services, or other segments, more transactions per second means more customer touches and more sales. So similarly on the right, we did a test with our top of stack versus Intel 8380. As you can see, again, we're delivering more than 2x the performance in critical OLTP transactions. Virtualization performance is a key factor that CIOs look at as they're modernizing their infrastructure. And VMmark is an industry standard benchmark that measured virtualization on servers. As you can see here in the VMmark test we've done, We're delivering almost 3x the performance versus our competitor, which is just tremendous advantage. And we're also delivering over 3x the density, which allows more VMs to be deployed. So this performance and density is critical, no question. But we all know that the data centers of today are also challenged in space and power. And packing in the most amount of compute in the smallest space and power is super critical as well. We wanted to take a look at how 4th Gen EPYC can enable enterprise virtualization. And we took an example of roughly a 2,000 VM deployment. And as you can see here, it would take about 15 servers based on Intel Ice Lake processors to deliver that workload. And on the right, you can see that we could deliver the same exact workload and density with 5 servers based on 4th Gen EPYC. Now think about this. The EPYC 9000 delivers the same exact output, but with 1/3 the servers, delivering that workload at 50% less power. And that combines to deliver a 40% CapEx and a 61% OpEx reduction annually. It's tremendous savings. And here's the best part. It's never been easier to migrate your VMs from Intel to AMD. And Forrest will show you that in a little bit. Now, I'd like to take a step back and look at 4th Gen EPYC at a higher level, a little larger scale, and take a bigger picture look at the server energy efficiency. So we looked at this using an example of about 1 million servers deployed in on-prem data centers in the US today. Imagine for a moment, and this is hard for me, imagine for a moment if all those 1 million servers were populated with top-of-stack Ice Lake processors. Very hard, but bear with me. To generate that same output, it would take 318,000 servers based on 4th Gen EPYC. 680,000 servers less with 4th Gen EPYC. No question, huge savings, right? Cost, acquisition costs, operating costs, just a tremendous win for the enterprise. But it gets actually more interesting. Those same 680,000 fewer servers actually will save over 4 billion kilowatt hours of energy consumption. And by the way, that's more than the energy consumption of over 400,000 US households in a year. And secondly, these same 680,000 fewer servers, they'll reduce CO2 emissions by 2.2 million tons. 2.2 million tons. And here's the other interesting part, and to put that in context, it would take 2.4 million acres of US forest to remove that much CO2 from our atmosphere in a year. And 2.4 million acres happens to be roughly the size of Yellowstone National Park. So we are talking about tremendous game-changing results, not only for the data center, obviously, but for our environment also. Now, let me close with a couple last thoughts. First and foremost, it's never been more important to be maniacally focused on the efficiency of server fleets, no question. And secondly, it's never been easier for enterprises to adopt 4th Gen EPYC and deliver higher performance, consolidate their infrastructure for overall cost savings, drive less energy, and take a huge leap towards their sustainability goals. So I want to thank you for your time, and now let me introduce Forrest Norrod to talk about our ecosystem of partners and also where you can get your hands on one of these EPYC servers. Thank you.
Thank you, Dan, and good morning, everybody. Before we get into where you can lay your hands on those sweet 4th generation EPYC servers, I want to show you why there's never been a better time to embrace EPYK. Dan just showed you, quite candidly, how much of a risk it is for enterprises and server customers to not switch to EPYK. From performance to consolidation and energy savings, AMD is the clear choice. Now, when we look across data centers today, there is an enormous deployment still of older servers. Servers that were from the Skylake or Naples server CPU generations or before. That's well over 5 years old in many cases. And moving from those aging servers, from that aging infrastructure, has many significant benefits because, quite candidly, just one AMD EPYK server can replace over 5 legacy servers. And the results of that consolidation are just incredible. 58% or more savings in energy costs per year. 80% reduction in the data center footprint while delivering more performance. And that consolidation is easy to do. With AMD EPYK, you can move your workloads, your applications very easily from those legacy servers onto that new modern infrastructure. In less than an hour, you can move 380 virtual machines from those 5 legacy servers using standard tools to a single 4th generation EPYK server. The energy and space savings, performance gains, and that simple migration, that easy transition, makes AMD EPYK the clear choice for the modern data center. I'd like to thank all of our incredible platform partners that were here today, that have been participating in the launch virtually, and that have produced an incredible set of platforms for past generations of EPYK and for the next generation of Genoa. And I'm very pleased and proud to say that across this list, the 4th generation EPYK servers, many of which are available today and will be rolling out further examples throughout the year, are going to be available on-premise or in the cloud for our customers to begin seizing these benefits that Dan, Mark, and Lisa spoke to. Now, beyond the platforms, turning to our ecosystem of solutions, when we began this EPYK journey back in Naples, just a few miles away from here, we began with this close set of partners, a small set of partners that were optimizing their software and hardware to work as part of the EPYK ecosystem. We've added to that ecosystem over the last 5 years, and I'm very pleased to say that when you look today, and you look at the names on the wall behind me, which are just a tiny fraction of our partners around the EPYK ecosystem, we have a complete ecosystem today. No matter what workload you're running, from finite element analysis to transaction processing systems, whether you're an enterprise with one of the largest data centers in the world, or if you're a small or medium business, EPYK and our partners' ecosystem is ready to run your workload in an optimized fashion today. Now with that, I'd like to turn it back over to Lisa to close out the morning. Thank you very much.
So I started at the beginning with saying our goal with EPYK was to build the best data center CPU roadmap in the industry. And I think we've done that. With 4th Gen EPYK, we have delivered another major step forward in performance and efficiency, making the best server processor roadmap even better. And we're really just getting started. So when you think about the 4th Gen EPYK family, we've really broadened the portfolio because the data center is becoming much more complicated. There are many more workloads, and optimized solutions can really bring a lot for specific workloads. So in the first half of 2023, we'll launch Bergamo, which is increased core density. It will allow us leadership scale out and particularly optimized for cloud native workloads. And as I said earlier, that product is looking fantastic in the labs right now, so we're looking forward to that. You heard Microsoft talk about Genoa X, and what we've seen with our 3D vCache technology is it adds tremendous capability for specific workloads, especially technical computing. So we're also ready to launch that in the first half of 2023. And then in the second half of the year, we talk about Sienna, which actually extends our EPYC portfolio into telco and intelligent edge, which really is focused on sort of maximum performance per watt at the right cost point. So you can see that we're taking the Zen 4 capability and really extending it through the entire set of workloads. I want to say thank you so much for joining us today. It is really our honor and our pleasure to be able to share with you all of the exciting technology. It's an exciting day for AMD. I think it's an exciting day for the industry. And our goal is to bring the best to the data center together with our partners. Thank you so much.